Hi, I'm Al Williams. I thought I'd show you how easy it is to use the GP-3 from AWC along with your PC to have digital and analog input and output with Labview. Labview is software from National Instruments. It's pretty well known and used to control all sorts of instruments and data acquisition hardware, and the GP-3 is no exception. Here I have an empty block diagram in the front panel for its behind here. I'm going to go to Select a VI, and I'm going to pick the GP3 Open component, which is one of the examples. It looks suspiciously like a serial configuration block because it's certainly based on that, but all the parameters that are set for the GP3 are built into it. So you'll see there's a Visa resource name, and in particular I'm going to make a constant for that. I could make a selectable piece there where you could select a different COM port, but for the purposes of this example I'm just going to hardwire it to COM1. Let's get a little extra space here. Whoops, I have too many COMs there. A little hard to work on the small screen for the recording. So there's COM1. And you can see there's an error in we won't use. There's an error out and a Visa resource name out, just like a regular serial block. And there's a 10-second timeout, which is fine. Now what I'm going to do is I'm going to make this program, or this VI if you will, light up the LED on the GP3, and I have a wire going from the LED output over to one of the analog to digital channels. So we'll also look at the voltage coming off the LED pin as we change it. So I'm going to go and pick my GP3 LED on-off block, which is another one of the examples, and I'll connect it along there. So you can see these inputs match up exactly. There's a error in and a Visa resource name. Visa is the device independent drivers that Labview uses to talk to instruments, including serial ports. And then there's a state. So what state do we want the LED in? And then there's also error out and Visa resource out, so that you could just keep chaining these together if that's what you wanted to do. It turns out we're not going to want to do that, as you'll see in a minute. I want some way to control the state of the LED, so I'm going to go make a modern rocker switch. That's going to set my LED state. Move that over a little bit, and I'll wire that over to the state Let's clean up that wire. So at this point, if you were sitting here, you'd be able to see we could run this repeatedly, and every time we hit the switch, the LED would either turn on or off depending on which way we flip the switch. That's not enough, especially since you can't see it without me digging out a camera and doing some editing. So what I want to do is I want to go back to Select a VI, and I'm going to get GP3AD, which is the analog digital converter on the GP3 board. And I'll put that about here. And you'll see that looks a lot like this particular block here, except it's got an output for counts, and instead of a state it's got a channel number. We're going to depend on the diagram running these pretty much in sequence. If you had a more sophisticated thing with loops and everything, you might have to do something to keep these running separately, and that's pretty easy to do. The examples on the website go into that in a little more detail. But for this, I'm just going to depend on it working okay like it is. I'm just going to wire these up the same way, the same way that we did for the first one. And I'd like a constant here. I just want a 0, so I'm going to tell it to create a constant. 0 is exactly what I want. I'm not going to use the Visa out and the error out. And now I've got these counts. And the counts will be 0 to 1023, representing about 0 to 5 volts. And I'd like to show them in a nicer way than just counts. So let's go to the programming palette, and under numeric we'll pick a multiplier. We'll drag a multiplier out here and make sure it connects to the counts. I'm going to make a constant. Whoops. Create a constant. And that constant needs to be the number of volts in a count, which happens to be about 0.004883. So each count's worth about that many volts. I'll probably need to clean up that wire a little bit, and let's maybe move that around. Clean up the wire. There you go. That's better. And then I want some way to actually visualize that. So let's try something a little fancy, but not too much. I'm going to go from the modern numerics, and I'm going to pick this fancy looking meter here. I'll drop that. You see it goes from 0 to 10, but we know our voltage is only going to be 0 to 5, so I'm going to go to Properties, and I'll tell it that the maximum is 5. Back on the block diagram, I've got this meter here, and I'd like to wire it up to the output of the multiplier. So if I didn't make any mistakes, that should do it. Now when you hit run, it'll just make one swipe through this, and that's not enough. We need to do this over and over and over again. There's smarter ways we could do that, like using a while loop so we'd only open the COM port once and things like that. But for the purposes of this example, I'm just going to hit this run continuously button, which will just run it over and over and over again. So remember, the LED is hooked up to the analog to digital converter, so right now we're getting about 0 volts, and if you could see, the LED on the board is turned off, and now it's turned on. And because of the dropping resistor and the LED, it's not quite 5 volts, it's 4 volts and a good bit of change, and that's about right. And when I turn the LED off, 0, 4.5, and so on. Very simple. Nice thing about Labview is you can sit and rearrange all this and change the colors and change how the switch looks, and you can even do lots of really fun things, like if I go over here to the graph, I could pick a waveform chart. Let's see, I don't really have room to put that down here, but I think I can move some things around. Well, that's not moving very well. There we go. And so now I've got this waveform chart on here, and I can wire it up to that very same voltage. I can come in here. I want to tell it a few things. I'll go to the color, and I'll pick a nice angry red color, and I'll go to the properties, and I'll tell it that my y-axis should not auto scale, but should in fact go from 0 to 5 volts. Actually, let's make it minus 0.5 to 5.5 volts. That'll give us a little bit of margin on the top and bottom so we can see the lines better. And so now, with just that very simple, drop that in and wire it up and change a few parameters, if I run continuously now, there we go. So as you can see, we've got 0 volts there on the graph. I flip the switch, we've got, again, about 4.5 volts, more or less. And there we go. Very simple, very easy to put together, and very easy to interface to the GP-3. If you want to know more, take a look at the document on our website. Best place to go is the GP-3 Center, which has a lot of examples for things like C and C++, Java, Visual Basic, and of course Labview. Go to www.awce.com/gp3center.htm, and I hope you'll visit us there and take a look at what the GP-3 can do for you. Thanks for watching.